In June 1944, at a remote airbase somewhere in the Pacific, a civilian stepped out of a transport plane and walked straight into the middle of a war zone. Not as a spectator, not as a consultant in a clean uniform, but as a man on a mission to teach trained military pilots how to fly their own aircraft more efficiently. That civilian was Charles Lindbergh. Yes, that Charles Lindbergh. The man who,
If you enjoyed this breakdown, don't forget to like, subscribe, and drop a comment. Your feedback helps shape what we cover next, and you being here keeps the conversation going. Thanks for watching. See you in the next one.
1927, crossed the Atlantic solo in the spirit of St. Louis. Now here he was, almost 2 decades later, tinkering with the engines of the P-38 Lightning, America's high-altitude, twin-engine fighter, claiming he could stretch its range by nearly a third. And the kicker? He said the solution was simple. Just run the engines in a way the military had explicitly told pilots never to do. This wasn't a theory scribbled on a chalkboard. This was Lindbergh flying actual combat missions with fighter squadrons, risking his life to prove that the official manuals were wrong. And he was right. He taught pilots to run their engines in what's called an over-square configuration, lowering the engine's revolutions per minute RPM to just 1,600 while boosting the manifold pressure, and switching to the auto-lean mixture setting. To the average listener, that sounds like minor technical mumbo-jumbo. But to any WWI pilot, that sounded like a death wish. Over-square operations were a giant red flag. Every bit of training warned them, doing this would fry the engine. Catastrophic failure. Mid-air engine seizures. That's what they expected. But Lindbergh knew what he was doing. His entire career was built on precision, on understanding the delicate relationship between airspeed, fuel burn, and engine output. He'd crossed the Atlantic in a plane designed to push the very edge of fuel efficiency. He knew how much more aircraft were capable of if you trusted the data, not the dogma. Naturally, the military brass was skeptical. Fighter pilots had been trained to avoid over-square settings like the plague. You don't just let a civilian, no matter how famous, waltz in and tell combat-tested crews they've been doing it wrong. But Lindbergh didn't lecture. He flew. He climbed into a P-38, took off with the squadron, and went on actual combat missions. Not joyrides. Not simulations. Real combat, against real Japanese forces. And every time, he proved the same thing. Not only did the engines not fail, but the planes were coming back with significantly more fuel in the tanks, and that meant one thing: range. This wasn't a 5% boost. Lindbergh's technique improved the P-38's combat radius by 31%. That's not a tweak. That's a strategic game changer. Suddenly, missions that were previously considered too risky, or flat out impossible were back on the table. The Pacific theater was a monster. Thousands of miles of ocean. Scattered islands. Supply lines stretched to the breaking point. Every drop of fuel mattered. If fighters could only go so far, bombers went unescorted. That meant high losses. But now, with Lindbergh's method, P-38s could fly longer, escort deeper, and strike further while still making it home. It wasn't just theoretical. MacArthur's island-hopping campaigns needed that kind of reach. His push through New Guinea, the Philippines, and beyond all benefited from these expanded flight envelopes. Lindbergh's method meant fewer refueling stops, faster advances, and more flexible tactics. Even better, it didn't come at the cost of safety. The military kept a close eye on engine failure rates, waiting for the gotcha moment. It never came. Operational records showed that engines operated under Lindbergh's system didn't suffer increased failures. In fact, pilots often returned with more fuel reserves than expected. That extra margin could be the difference between ditching in the ocean or landing safely on base. This wasn't magic. It was math. Lindbergh's background wasn't just as a daring aviator. He was meticulous. Obsessive. He understood the way fuel burned at different altitudes and engine loads. He knew that the published range of an aircraft was often a conservative estimate based on safe defaults. But those defaults weren't sacred. They were a starting point for optimization. What made his contribution so effective wasn't just the technique, it was the credibility. He didn't just tell pilots to fly differently. He showed them, in the cockpit, with bullets flying and lives on the line. That kind of leadership doesn't come from a rank. It comes from skin in the game. And slowly but surely, the culture started to shift. At first, it was just whispers between pilots. Then squadrons started trying it on longer missions. Eventually, the data became impossible to ignore. The military officially adopted the practice. Over-square operation, once practically heresy, was now doctrine. And Lindbergh, the outsider, had changed the way America flew in war. His impact went deeper than just mechanical technique. He proved that innovation could and sometimes must come from outside the chain of command. That expertise doesn't have to wear a uniform to be valuable. And that sometimes, progress requires challenging the very assumptions we think are untouchable. There's a lesson here that's bigger than just WWIA. Institutions, especially in high-stakes environments like the military, often default to tradition. It's safe. It's proven. It avoids disaster. But it can also stifle innovation. Lindbergh showed that with enough knowledge, enough data, and enough courage, those walls can be pushed. And that courage wasn't just technical. Flying in combat zones as a civilian, voluntarily putting yourself in danger just to prove a fuel theory. That's not a consulting gig. That's conviction. That's leadership by example. His success also reinforced the value of rigorous testing. These weren't hunches. The improvements were backed by numbers, fuel logs, engine diagnostics, mission debriefs. The U.S. Army Air Forces didn't just take Lindbergh at his word. They saw the mission results. The drop in aborted flights, the rise in fuel savings, the expanded operational capabilities. And that changed everything. Fighter pilots started looking at their manuals differently. Mechanics reevaluated what engine parameters were really safe. Commanders began to see the value of technical optimization, not just brute force. That openness to outside expertise trickled into other aspects of military planning, fueling a culture that, slowly but surely, became more data-driven and less bound by habit. Lindbergh wasn't the only reason the tide turned in the Pacific, but his influence rippled outward mission by mission, squadron by squadron. And the P-38 Lightning, already a formidable aircraft, became even deadlier, more flexible, and far more capable because of one so-called impossible trick from a civilian who refused to accept it or you less at face value. So, what does this all mean? It means that in a world full of regulations, routines, and resistance to change, real progress still finds a way. That sometimes, the person with the most valuable insight isn't the one with stars on their collar but the one who's done the math and is willing to fly into combat to prove it. If Lindbergh had kept his ideas to himself, if the military had ignored his input, countless missions might have failed. Pilots may not have made it back. And the Pacific War could have dragged out even longer. Instead, one man with a calculator mind and a pilot's heart stepped into a war and changed the rules of engagement, not with a new weapon, but with a better understanding of the ones they already had. Let's be real, this is the kind of story that deserves more attention. A quiet revolution inside a roaring engine bay. So if you found that as wild as we did, hit that like button, share this video with someone who thinks fuel efficiency is boring, and drop a comment. Did you already know Lindbergh pulled this off? Or is this one of those historical side quests they never taught in school? And if you want more stories like this about people who shook up the system from the inside, make sure you subscribe. We've got more coming. Let's get into how exactly this all unfolded, because while it sounds clean in hindsight, this was not some instant overnight win. The resistance Lindbergh faced wasn't just from higher-ups worried about engine damage. It came from pilots who lived and died by the rules written in their manuals. These weren't men looking for shortcuts. They were already flying brutal missions in a theater where fatigue, heat, and enemy fire were daily realities. The last thing they needed was a civilian telling them to mess with the engine settings. You have to understand, over-square engine operation was basically aviation blasphemy. Every flight school drilled it into their heads: never let manifold pressure exceed RPM. It was hammered into their training as a guaranteed way to destroy the engine. So when Lindbergh showed up saying, "Actually, you can do this safely if you understand the mechanics," he was stepping into a hornet's nest of deeply ingrained beliefs. But that's what made his approach work. He didn't condescend. He didn't pull rank. He didn't have rank. He rolled up his sleeves and proved it the only way that mattered, by flying with them, in the exact same conditions, on the exact same missions. And his presence alone was a shock. Lindbergh was a celebrity, an icon from another era. His rival wasn't just some quiet technical consult. It was like dropping a rock star into a frontline squadron. But instead of basking in the glory, he kept his head down and got to work. He flew dozens of missions, some accounts say as many as 50, racking up combat hours and earning the respect of pilots who had every reason to doubt him. The numbers started rolling in. Pilots using Lindbergh's technique weren't just flying further, they were flying smarter. Missions were getting extended. Escorts could now stay with bombers longer. More aircraft were making it back with fuel to spare. In a war where margin for error was razor thin, this was the edge they needed. Even skeptical engineers began taking notes. What Lindbergh understood better than almost anyone was the relationship between engine wear and power settings wasn't as simple as military doctrine suggested. The idea that high manifold pressure automatically destroyed engines only held true under certain conditions. But when combined with lower RPM and the correct mixture settings, specifically the auto lean mode, it actually reduced the stress on engine components. Less vibration, lower cylinder head temperatures, smoother combustion, all backed by cold, hard data. The implications went beyond the P-38. The same logic could apply to other aircraft with similar engines. The key wasn't about flying dangerously, it was about flying precisely. Lindbergh's method was rooted in physics, thermodynamics, and mechanical efficiency, not guesswork. He understood fuel as a resource that could be optimized, not just consumed. It was a shift in mindset as much as it was a shift in technique. And this was happening in the middle of a high-stakes war effort where time, fuel, and manpower were stretched thin. Every gallon saved meant more bombs dropped, more targets reached, and more lives spared. It also disrupted the culture of rigid top-down control. Military operations, especially during wartime, thrive on standardization. That's how you keep massive organizations running. But standardization often leads to stagnation. Lindbergh was a reminder that knowledge, not hierarchy, drives innovation. The Army Air Forces eventually embraced his methods, but only after they saw the undeniable results. There were no committees, no lengthy proposals, just numbers, missions, and returning planes. Lindbergh didn't ask for permission to rewrite procedures, he let the battlefield make the case for him. And here's the twist in all of this: Lindbergh had been a deeply controversial figure before the war. His pre-war political stances and isolationist views had tarnished his public image. He was, for a time, persona non grata in Washington. But in the Pacific, none of that mattered. His reputation wasn't riding on politics, it was riding on whether or not pilots could get home safely. He rebuilt trust in the most dangerous way possible by proving his value where it counted most, in the sky, under enemy fire, helping real people survive longer missions. And in doing so, he helped tip the scales of the Pacific War. MacArthur's strategy, leapfrogging across islands, cutting off Japanese supply lines, and isolating strongholds, relied on flexible air power. Lindbergh's efficiency breakthroughs allowed fighters to stretch further into contested territory, hit harder, and return more reliably. That meant faster momentum, more pressure on Japanese defenses, and ultimately, a quicker path to victory. But this story is also about how we innovate, not just what the innovation is. Lindbergh didn't build a new plane. He didn't invent a new engine. He rethought how to use what already existed better. That's a different kind of genius. One that requires courage, not just brains. Because challenging the way it's always been done is risky, especially in war. He faced doubt from all sides. And still, he flew. He wasn't just tweaking a carburetor. He was rewriting doctrine from the inside out, using nothing but his brain, his flight experience, and his total refusal to accept assumptions without proof. And what's more, he did it without ego. There were no parades, no press releases. Most people today still don't know he played such a critical role in operational air strategy. But those who flew with him, they knew. They felt the difference. They saw it in their fuel gauges, in their mission reports, in their survival rates. And it wasn't just the pilots who benefited. Commanders started to rethink other operational constraints too. Maybe the listed range of an aircraft wasn't the limit. Maybe logistics could be optimized. Maybe a bit of civilian expertise could make all the difference in a military system that often prized tradition over transformation. That's what Lindbergh brought, not just a technique, but a mindset, a willingness to question, test, and improve relentlessly. He turned the P-38 from a fast, capable fighter into a long-range, multi-role weapon that could stretch its legs deep into enemy territory. And in a theater where distance was everything, that made all the difference. The legacy of his contribution isn't flashy. It doesn't show up in Hollywood movies or pop culture history books, but it lives on in how aviation evolved after the war, in how engineers began to rethink performance limits, in how flight manuals got rewritten, in how pilots learned to trust the math. This story isn't about daring dogfights or dramatic shootouts. It's about quiet, relentless experimentation. About one man showing up in a war zone and changing the game not by fighting harder, but by thinking smarter. And it's a reminder that sometimes the most powerful innovations come from those standing just outside the spotlight, armed with knowledge, data, and the courage to prove everyone else wrong. Here's the part that really drives it home. What Lindbergh did wasn't just about saving gas. It was about proving that thinking differently could be more powerful than thinking bigger. Everyone else was focused on new aircraft designs, heavier payloads, faster engines, longer runways. The usual military mindset: escalate, expand, outbuild the enemy. But Lindbergh looked at the problem from a completely different angle. Not what else can we add, but what are we already doing wrong? That's a much harder question to ask. It requires humility and a willingness to face resistance from people who think the manual is the law. And think about how rare it is, especially in war, for someone to say, maybe we're not using the tools we already have correctly. That's not dramatic. That's not flashy. But that's precisely why it worked. The genius of Lindbergh's approach was that it didn't need new manufacturing. No special materials. No high-level budget meetings. Just better understanding. The P-38 Lightning was already one of the most advanced fighters of the war. But without Lindbergh's input, its range limitations kept it tethered. With his method, it became something else entirely. A long-range escort. A surgical strike asset. A plane that could project power across islands and oceans in ways that nobody thought possible. And if you've ever read anything about the Pacific Campaign, you know how brutal the logistics were. Airstrips carved out of jungle. Fuel convoys under constant threat. Every extra mile a fighter could fly without refueling was a logistical miracle. It freed up tankers. It reduced supply chain risk. It gave commanders options they didn't have before. But the truly wild part, none of this required re-engineering the aircraft. The P-38 didn't change. The thinking did. And Lindbergh's influence didn't end with his last combat mission. What he did had ripple effects. After the war, military aviation began to take fuel efficiency and engine optimization far more seriously. Not because of theory, but because of what Lindbergh proved in practice. It validated the idea that pushing boundaries safely isn't just possible, it's necessary for evolution. So yeah, while other stories from WWI involve tanks, invasions, and dramatic turning points, this one is quieter but just as important. One man, one tweak. A massive shift in how war was fought across an entire theater. It's a reminder that the biggest impact doesn't always come from the loudest action. Sometimes it comes from someone flying under the radar, literally changing the rules by doing the unthinkable and getting it right. That's the legacy Lindbergh left in the Pacific. And for all the controversy, all the doubt, all the whispers about his politics, what he did in that cockpit can't be erased. When everything was on the line, he chose to fly, to prove, and to change everything. So if you're still here, you probably appreciate stories where brains beat brute force, where data rewrites dogma. Hit the like button if this blew your mind even a little. Share it with someone who still thinks old rules can't be challenged. And drop your thoughts in the comments. Should we be telling more of these overlooked war stories? And definitely subscribe if you want more drama, more chaos, and more how was this not a movie yet moments. We've got you covered.